hollows and are perforated with circular holes. For cirrostratus, there are only two species, Cirrostratus vibratus, which again are very similar to Cirrus vibratus but a bit more sheet-like, and then Cirrostratus nebulosus, which is a very thin, sometimes imperceivable high-altitude sheet of ice. Sometimes the sun will hit them just at the right angle to make a spectacular shining halo in the sky. Then we have altocumulus. There's altocumulus stratiformis, which are low-lying sheets of puffy clouds. Altocumulus lenticularis, those are the cool stationary ones. Altocumulus castellanus, which are very puffy towers. And altocumulus flocus, which are more little tufts of wool. Altocumulus lacanosus are basically the same as cirrocumulus lacanosus, just a tad closer to the ground, in the mid-atmosphere. We're doing all things clouds, so if this feels like a lot, you better strap in. Next, we have altostratus, some of which are actually pretty cool. First, there's altostratus undulatus, which look like little waves or rows, as undulatus basically means waves. Altostratus duplicatus is just when two layers of altostratus clouds are on top of each other. There aren't any pictures of this because, well, one layer blocks the other. That's how it works. But typically, because there's more than one layer of clouds, they'll block out more light. Altostratus panis are very chaotic and look like they were ripped away from other clouds. Altostratus translucidus are very thin, and if you couldn't tell, is translucent, meaning you can see the sun through them. Then there's altostratus opacus, which are basically the opposite, meaning you cannot see the sun through them. Altostratus radiatus are like vibratus clouds, but all filled in, running parallel to each other towards the horizon. And lastly, we have altostratus mammatus, which are fun. They're like hanging pouches and are named after mammaries. They're also pretty rare. For plain stratus clouds, we have stratus fractus, which are just small sheets fractured from larger mother clouds due to high winds. These change very quickly and don't last very long as a result. Stratus nebulosus is another thin, foggy cloud layer, this time much closer to the ground. Stratus undulatus form low-lying cloud waves. These are quite rare and hard to spot, so don't really worry about them. Next, we have stratocumulus clouds. First is stratocumulus stratiformis, which, if you're counting, is two mentions of stratiform in one name. These are the most common types of cloud cover in the world. They're basically fluffy, flat clouds that split often. Then there's stratocumulus cumulogentis, which are the flat clouds blown off the puffy tops of other cumulus clouds. And we also have stratocumulus castellanus and stratocumulus lenticularis, which are very similar to other forms of castellanus and lenticular clouds. Stratocumulus lacanosus are similar to panis clouds, with many holes perforating the body of the cloud, looking like it's being torn apart. Now we're on to cumulus clouds. First, there's cumulus humilis, which are small cotton ball clouds that are more wide than they are tall. They're often called fair weather clouds and usually occur in groups during the summer. Cumulus mediocris are essentially the same, they're just equally wide as they are tall. And then cumulus congestus are the opposite, taller than they are wide. Lastly, cumulus fractus are the tiny bits of cumulus clouds ripped away from one another by the wind. And I saved the best for last, the cumulonimbus species. First, there's cumulonimbus calvus, which are puffy all over, even on top. This means the water droplets at the top haven't reached temperatures cold enough to freeze into ice crystals. Once this happens, however, the top ice crystals spread out and become fibrous, and the cloud becomes a cumulonimbus capillatus. This is when the cloud begins to take on an anvil shape, roughly. Once this happens for a while, the cloud becomes what's known as a cumulonimbus incus, the final form of a thunderstorm. These can grow to truly massive sizes, and if they become powerful enough, they can form what's known as a supercell, which is basically a miniature hurricane. These are the conditions which create tornadoes, which can be some of the most dangerous natural hazards on the planet. So that's it, right? Well, in 2017, a new type of cloud formation was added to the official list of cloud types. The asperitas cloud type is extremely rare and not entirely understood, but it can be identified by having waving or rolling undersides, similar to the undulatus species, and looks super cool. If you see one of these, count yourself lucky and take a picture. Alright, that's all for classification now, but there are a few phenomena I think are worth mentioning too. Here's some iridescent clouds, which you only get when water droplets in a cloud are a particular size and correct angle to scatter incoming light as color. Then these are what's called morning glory clouds, oddly satisfying rows of clouds so rare that only one place on Earth has the conditions for them to form, here in the Gulf of Carpentaria, Australia. This is what they look like from space, though it's still unknown how exactly they form. These clouds have features called Kelvin-Helmholtz waves, formed when two layers of fluid at different densities slide against each other, shearing away the top and bottom of the layers. Helios clouds form when mother clouds grow too rapidly and usually form around a cumulonimbus right before it starts to rain, but can also form around other cloud types as well. Here's one forming on an ash cloud from the eruption of Sarashev Peak. Okay, I think that's it for now. Let me know if there's anything else you'd like to know about clouds, or if I missed anything. Thanks for watching until the end. I hope you enjoyed this video, and if you did, please consider liking and subscribing to the channel, where I'll be making more videos like this in the future. Thanks!